Over half of all websites still use jQuery to select elements in a DOM, and most of the functionality it offers probably isn't being used. So in this video we'll create a lighter alternative using TypeScript with no extra dependencies. Hey guys, and welcome to Azul Coding. To get started, I've set up some basic HTML and CSS, which we'll use later on in the video to demo our jQuery alternative. We'll create the iconic $sign function in this azulquery.js file. All the code is available from the link in the description down below. I'll be using TypeScript today, but there's a JavaScript version available from the link as well. So let's start by writing the code for our jQuery alternative. If you're familiar with jQuery, you'll know that you need to call the $sign function with a selector string, and then you can add on multiple function calls after that, such as class. To achieve this, I've created the $sign function up here, and this will return a class instance that will contain the extra functions. In the class, we're storing a list of elements returned by the selector thanks to the querySelectorAll function, and the functions in this class will access those elements. This sort of setup is good if you're just using those functions on the end, but if you want to access the raw elements returned by the selector, using an index like this won't work just yet. To make this work, we'll need to make some changes. I'm going to start by adding in a helper function called create that will return a proxy. This means that whenever we access a property in this class, it passes through this proxy, allowing us to return different things. Let's take a look at this line again. Essentially, what we're doing here is accessing a property called 0. Even though this is an integer, it gets passed through to the class as a string. So in our proxy, when we're looking to get a number, we'll pass the string and return the element at the relevant index. Otherwise, we'll perform the default behavior and get the property from the class itself. Now I'm still getting an error down here, and that's because TypeScript doesn't know that the class accepts number properties, so let's add this line in here to resolve that. We'll also make the constructor private and call our new create function up here instead. I can now access the raw element, but if I try and click this button, TypeScript gives me another error, and that's because it sees the result as a generic element. I could do something like this to fix this issue, but let's make our class a bit more intelligent and introduce some type generics. As you can see, I've added loads of t's to our $sign function and class, where t is something that extends a generic element. So we can now call our $sign function with HTML button element like this, and this means that all elements returned by the selector should be treated as buttons. And now the error on the click function has cleared. So we can call our $sign function with a string. But what if I have an element that I've created? Let's see if we can accept raw elements as well as strings. I'll start by updating the selector type here. Now we're accepting a string, t, which is something that extends off the generic element, an array of t, and node list of t, which sometimes gets returned by certain JavaScript functions. I'll update the selector type in the create function, and then move on to the constructor. If our selector is a string here, we'll do the same as before. If it's an instance of the generic element, we'll just create an array of that element. If it's a node list, we'll simply convert that to a standard array, and if it's an array, we can simply set that to elements directly. Now what if I wanted to loop through the elements in this class instance? It looks like this needs an iterator, so let's add that in. All this does is loop through the elements array and yield each element in turn. For completeness, we can also include a get function to return the full array and a length property like so. Now we've set that all up, let's add in each of the helper functions. Let's start off simple with some class-related functions. The add class and remove class functions are pretty self-explanatory. Toggle class will toggle a class with the option to force whether a class should be included or not. And lastly, has class will return true or false based on whether a class is present. In each function, except has class, we want to return the same class instance, so we can continue to chain on extra functions like this. We'll now move on to the text function, which behaves in two different ways. If the content parameter isn't provided, we'll get the text content to the first element, but if it is provided, we'll need to set the text content. This means the function will either return a string or the class instance. To make it clearer when we're calling the function, we can use function overloading like this. Here we're saying that if no parameter is provided, the function will return a string, and if a content parameter is provided, we'll return the class instance. Be sure to keep the declaration at the end, which combines each scenario together. In VS Code, when I call the text function, I can now see the different function declarations. We can create a duplicate of this function and call it HTML to use the in HTML instead. Now let's move on to the attribute function, which gets a bit more complicated. If we provide a simple string value to this function, this means we'll get the attribute value back, or undefined if the attribute isn't there, and if we provide a second value parameter, we'll need to set that value to the attribute and return the class instance. We're also going to allow for a record or key value object to be passed in, so you can define multiple attributes at once. And so we're left with the following combined declaration. We can then perform the logic for getting an attribute value, setting a single value, and looping through the given object entries to set multiple values. I'm also going to include a simple function down here for removing attributes. We can do a similar sort of thing for properties as well, for example the disabled property. We're using a similar flow to before, but instead I'm accessing the property with the provided name here. I've also got a remove prop function that uses the delete keyword to remove a particular property. The next function I'm going to add in is called CSS, and we'll use this to update the styles of an element. We're using a similar setup again. First off, we're returning the value of a CSS property using getComputed_style on the element, and then getPropertyValue afterwards. And when it comes to setting a CSS property, we'll first check if the element supports styles, so either a HTML or SVG element in this case, and then we'll call setProperty. Let's add a helper function to add event listeners to elements. We could use this function declaration, which will work just fine, but notice the difference here. When I call add event listener on a button element, I get a list of possible events, but I don't get that with our function. To achieve this, we'll need to create a new type that specifies a list of possible events. Here we're saying if it's a HTML element, we'll use the HTML element event map. Otherwise, if it's an SVG element, we'll use that map, and otherwise we'll default to the generic event map. Let's update the declaration up here. And now it works. Let's take a quick break from the complicated functions by adding in show, hide and toggle functions. We're simply setting the display CSS property based on whether we're showing or hiding in the element. Now let's return back to the complicated functions again with some traversal functions. Let's say I want to find all elements within a particular element. Because this could be a different type of element to our original selector, we'll need to add in a second type generic. This tells TypeScript that we're returning a different type of element from this function. I'll add in a type generic u to this function, and I'm using a set to get a list of all matching children without any duplicates. The parent function will map each of our elements to its parent element, filtering out any null values and returning a new class instance again. Let's get the previous element with an optional selector string. For each element we'll get its previous event sibling. Then we'll use a while loop to iterate through all the previous elements and see if they match the given selector, if any. We'll add those elements to an array, making sure there are no duplicates, and this will continue until we run out of previous elements. Let's create a copy of this function for the next elements using next element sibling instead. To add new elements or HTML strings, we can use the append function. If we're adding an HTML string, we can use insert adjacent HTML with the before end value. If we're adding a raw element, we can use append child, making sure to clone the elements here. And if we pass in a class instance, we need to loop through the elements and add each one. If we're working with input fields, we need a helper function to get and set the value. We can use function overloading again and either return the value as a string or set it across all the elements we have. And let's finish off with a simple remove function to remove elements from the DOM and an empty function to clear the inner HTML. We've now finished the implementation part, so let's test it out. I'm going to expose our $sign function in the window for testing purposes, but if you're using this TypeScript file as a module, you can simply export the function like this. I've then compiled this to JavaScript so it works in the browser. I've added some simple elements here, so let's start off by changing the classes of one of the squares. As you can see, I can chain functions together like this, and now use a CSS function with some key value pairs to change multiple properties at once. And we can also access the raw elements here, either with get or with an index property. I can also change the text of this button here, set its disabled property to true, and hide it completely. Let's look at one of the traversal functions next. I can select the blue square and get the previous element, which will be the white one. I'll append some HTML to the blue square, and then I can use find to retrieve it. And we'll finish off with a quick event listener that will clear the HTML from the blue square. Of course, this isn't a complete implementation of jQuery, but it should be enough to get you going with the option to add more functions as you like. If you've got a spare moment, take a look at the suite of desktop and Android apps that I've made, and they're all open source. And check out Dablats to brush up on your language skills for free. The link to these projects is in the description down below. Be sure to leave a like if you enjoyed this video, and subscribe to keep up to date with the latest from Mozilla coding. Thanks for watching, and I'll see you soon.